have been constructed, but their dimensions are not the wished ones. These lab test equipments fill half of a big room or so. This is not what the amplifiers, some 5,000 meters deep under the Atlantic waters, would like to be. So efforts have been made and are made and will be made to miniaturize the optical amps of optical signals as refreshers, as relay stations, as fresh horses, so to say. But. And for the time being, there are electronical amps are available, but much slower and with all these critical negative implications I spoke of at length. Linus Torvalds, above whom I probably should say a little bit, for some time in his life had the email address Linus Torvalds buried in email. This is another reason why I have to be a little bit selective. Oh yeah, this is a good impromptu before we start with quantum computing. In 1991, Torvalds was a 20-year-old software engineering at the Technical University of Helsinki, Finland, somewhere outside the center. Could you put his name on? Torvalds, simple T and V. D, ja. So, ja, S.
Ja, S.
Thank you. It's okay. And the big Intel news of that year was that Intel finally, after so many lost years, had brought out a perfect, almost perfect computer data path, 22-bit wide, and that was a double of the usual Intel chips, and demanded by nobody else than the Pentagon, the kernel, the chip kernel, and was composed of several so-called rings of security. The innermost ring, the ring number 0, was, let's say, reserved for general staffs, for staff officers. The second ring number 1 was for officers. Ring number 2 for sub-officers, and number 3, the final one, was for us, private soldiers. This introduced some more hierarchy into the system, but much more security against interception and data and command loss. And my little team, then based in the Ruhr region of Germany, Bochum, had the same idea as Linus Torvalds. We wished to develop, to write a new operating system, a free operating system based on this 32-bit architecture. But we had to do other things, teach German literature and so on. And Linus Torvalds was free as a student to do what he liked, and so he wrote the first kernel of Linux as a single writer, just for him. And only later female friends of him came into play and contributed to the kernel, and the kernel grew and grew, and now it's almost as big as Microsoft or Apple kernels, but more versatile, flexible. One sentence about the singularity of Linux as the sole author of the first kernel version. It's supposed very often, especially in leftist circles, that computer languages and operating systems reflect social, cultural trends, and therefore are written by small teams influenced by their environment. But when one of these social cultural researchers met a certain McCarthy and asked, as a leading writer of programming languages in Boston, Massachusetts, he was kind enough to give her, the German researcher, an interview, and she asked him about social cultural context of his language. Lisp, I've mentioned, and he smiled and said, "Oh no, there are no social cultural influences on me. I write it quite alone." But so far, so much about the contribution of single persons to the course of history. Now I could have an whole hour to explain you the latest and most promising step of computing in the foreseeable future, but I'm not able to fill out this 60 minutes, and so please think about your final questions. Tomorrow midday we'll fly back to Berlin. This trend is called quantum computing and is in some way a straight continuation of optical communication systems. Optical computing as a universal discrete machine is far away in the unforeseeable future. It would be wonderful and speedy as light, but we can't describe it at the very moment as feasible. So many elements of the flip-flop type are still missing, to my knowledge. Quantum computing is on its way since 1 decade, let's say, and it breaks with the basic rules of silicon technology. as we had it in our discussion, silicon between us, silicon technology plays in the range between the molecular and the atomic in this range, really range, inside these bands. And quantum computing is a resolute step below to still lower levels of nature, of natural phenomena, of solid state physics, to remind you of what we said this morning. The feedback between computer technology and physicists' knowledge of the finest and smallest structure of material as such. Quanta, you may have guessed surely, is a term derived from quantum physics as it arose at Göttingen University in the 30s, and by men like Johann von Neumann or Dirac from England, Niels Bohr from Denmark, and so on, and under the Schirm, the shield of the great David Hilbert. And Hitler's race politics destroyed this circle, and by doing so confronted this circle of quantum physicists with Einstein and his followers or students with the deterministic theory of relative and absolute relativism in nature. Quantum physics is non-deterministic, and the question how high above quanta phenomena this uncertainty principle reaches is still an open one, but it reaches obviously higher than expected before. I mean, I've said controversy, I've said a little bit too less, too few. It was a crash between two fundamental theory of physics, of the physical universe, and this still continues it to be. I'm only informed by my friend Peter Weigel and have to leave it by this allusion. But I come back in some minutes to this struggle or battle. Quantum computers, if feasible on a large scale, will repeat the decisive step we have made from electrics to electronics. That is the step in the direction of storage, not just the flow of electrons as in electronics, stopped and stored by flip-flops, but a flow of quanta, electrons or photons, or in the future even quarks or so. And the possibility, the technical possibility to stop this flow for any desired time. Shannon's labyrinthic mouse comes into my mind, and its tragic end with all four walls closed. This was no way out of the labyrinth for Theseus, but the mouse was trapped, as Shannon showed it in this movie. And from this negative meaning of trap, it is a big and important step to a positive sense of trap. And quantum traps, electron traps, is this heart of quantum computing. The free flow of electrons or other particles is trapped into traps, and the barriers between traps can, on the other hand, be tunneled like birding for 50 minutes. So the complement or opposing two concepts of electron trap and electron under tunneling underlie the whole concept of quantum computing as far as I am able to tell you. Once trapped by nanotechnical means, remember what I said on nanotechnology or nanophysics, this particle can be read out, so to say. And this reading out of the states of this particle has not only two phases, 1 or 0, as it was in electronics, but depending on the number of electron trajectories, circles or ellipses, in the sense of Johannes Kepler and Niels Bohr, the electron is read out in 2, 3, 4, 6, and so on states in one and the same act of reading. The atoms, as you know, and their particles are defined in the Mendeleev periodic system of chemical elements by their numbers, and that is by the quantity of trajectories of electrons. Among other things, it informs us about the different number of circulating not electrons, but electron phases or states or phases. Arrived at this very limit of my knowledge, it's just important to see the Springenpunkt, as Germans say, the turning point, the point in the central point, the point which makes the difference between silicon computers and quantum computers. Each unit of storage and information is not just able to give you the answer 0 or 1, but it gives you many answers if asked or read out, as I call it. This means, in principle and in hope, that a massive parallelism is introduced into the deepest level of computing. You have always already, to say it with Heidegger and Derrida, many states and many informations in one spot. In comparison with the simplicity of electronic storage devices, this is the decisive step beyond, but also the big technical or nanotechnical problem. The reading out of these parallel informations, plural, must be non-destructive of the states, and this is difficult to avoid, thank you. But it has been done and it will be done on more and more larger scales. My last information, but this info isn't the newest of newest date, was that some lab has succeeded to read out 4 bits in one spot. Four bits means 2 power 4. That means information running from 0 up to 2 power 4 minus 1. That is to 15. Yeah? You followed this little arithmetic exercise of mine? Because we always include 0. We can't reach 16. For doing so, we should start with 1 instead of 0. So the highest number to get from this one quantum particle is not 16, but 16 minus 1. Yeah?
This number 15 came up yesterday.
No.
Day before?
Yeah.
With 0 to 9 plus 5.
Did come up yesterday
It came up in the last 2 days.
in the class, yeah. Yes.
Was that the grounding of this?
No.
No, unrelated. Okay.
The hexadecimal code we talked about is just an engineer's convention to count not from 1 to 9, but from 0 to 9, but from 0 to 15 in one step. Logic, you're right, structurally it's the same phenomenon, but the difference between a technical convention and a physical exploit is an abyss.
Yeah.
But it's important to see these tunneling between different fractal levels. Sometimes I like to think and to say that mathematics, since the Greeks, is not progressive, makes no progresses, but it's recursive. It comes on more and more deep level, on deeper and deeper level, always back again to questions posed for the first time by the Greek scientists. And so it may be with physics that and computer technology that some underlying principles as the powers of two repeat and repeat, go repeat and repeating. And now comes our turn once again into a math teacher in a primary school or in the first classes of high school. Given the number 15, is it prime or not?
No.
No. Right. It is. Instead, it's 3 times 5. And 3 is prime and 5 is prime, and so no other so-called factorization is possible for the non-prime number 15. The prime factors of 15 are 3 and 5. Next question, the number 13, is it prime or not? Right, yes. Obviously, it has no prime factors below, and this is precisely this has been the goal of this physicist lab experiment, which succeeded to do the so-called factorization of numbers ranging from 1 to 15 in one command, one step. The classical software command to factorize all numbers from 1 or to up to 15 would take about 20 steps, I guess. Having written a prime factor program myself in Intel assembler. But the difficulty of factorizing non-prime numbers rises exponentially. So higher primes in traditional hard-end software will take the computer seconds, then minutes, then hours, and finally days and weeks. Only certain prime numbers following some laws known since Pierre de Fermat can be handled in astronomically high degrees, powers of 2, and the actual record or the actual record for prime number discovering among non-prime numbers has arrived at incredibly high level due to Linux computer farms. These are desktop computers always connected day and night, but active only for this big prime program when for the given user it's night, that is when he sleeps. This is in this case the sense of the word farm. Every year a new biggest known prime number becomes public, and it's a real sport, and that's why it's a chase for records.
How many are there now? Hundreds, thousands?
More.
Can we not
More.
Two power 10,000 or so. Yeah, really. It comes near the number of atoms in the known universe, as it is the case in chess, combinatoric logic. The number of possible steps or moves in chess is decidedly higher than the number of the universe's atoms. This is my information about the actual limits of functioning quantum computing, maybe superseded by 2 power 5 or even 6. You can easily look up it under many web addresses. I'm not, as Tanya rightly remarked, I'm an old book reader and writer, and I'm not chasing for newest information, but for general trends and structural relationships. But may you ask or contradict me, who except Linux fans and young mathematics students, who is crazy enough to chase for prime factors of big numbers, of growing big numbers?
It's the army, right? No?
Yeah, some part of the army.
For encoding. So.
For encoding and decoding. And so it's probably more closer to truth to say not the army as an armored entity or corporation so much, but the most advanced encoding and decoding part of the politico-military system of Washington DC, that is once again the NSA, sorry. If I'm correctly informed, the battle or the duel between 3 or 4 global players in crypto analyzing cryptographic messages has come more or less to a deadlock. As long as every of these agencies still uses silicon hardware and programming languages based on the properties of silicon atoms. Intermediate remark. I've often been accused for what my critics call Kittler's media materialism. I have written an article, as you may know. There is no software, there's only hardware. But I hope in the course of these 3 days I've given some arguments for my viewpoint. actual cryptographic codes are based on properties of very big prime numbers, which then are multiplied, two prime numbers are multiplied one times the other, and this then gives a cryptographic key, so-called key, of incredible strength and length in binary digits. And the factorization is painful but feasible after, as I said, days or weeks or months. But as my example yesterday morning on the necessity of real-time decoding during World War II proved to show this real-time decoding, or fastest possible decoding, is not just important but it's decisive in any given strategic situation under conditions of peace and of those of war, future war, I mean, info war as it's called. And as the young rebels in, like Alan Turing had to experience during World War II, theory of numbers, Zahlentheorie in Deutsch, believed for many centuries to be the purest and immunest and most immaculate part of mathematics, has been maculated and contaminated more and more by blood and tears and dead people, bodies. Hardy came, the good old Hardy, Cambridge professor, England, was the last one to believe in the purity of pure mathematics. Now it's not just an applied, pure and applied at the same time, but it is a strategic weapon, and who knows the best, the highest, the best algorithm to factorize big numbers is virtually always already the winner of the future conflict. And this is, everybody has consciousness of this, and every Rand corporation and its Chinese or Russian counterparts know it since decades. And that is why the battle on this line has been so strong the last generations long. And the Pentagon is brilliant in it's really brilliant in its actual esteeming the situation and its scientific possibilities. I think in the 80s, they in the Pentagon started with the concept of electronic warfare. Later on, they became aware that electronic warfare in fact is warfare about command, communication and control, and they called it CCC, they are fond of elegant acronyms. And later on, they became aware that it's not just command, control, command and communication in this hierarchic order, but all this is to be linked to the computing power of the best computers on this earth. And so CCC developed or C power 3 developed into CCCC or C power 2. Command, control, communication, and computers. You may check this on the Wikipedia or elsewhere. I just give it. I just give my information as I got it and as I had it when I organized an Ars Electronica event on codes as such, some 5 years ago or so, 6 years. And now, a very funny look into the present and the future. And coming back to the struggle between Einstein and the quantum physicists. Einstein had predicted in a famous Princeton paper that two quanta distant in far distance, one from the other, could not partake anymore their fundamental identity. They could not be coupled in this sense. While this would mean breaking the laws of relativity itself, and it would mean to break the Einstein's universe, in which Einstein's famous sentence should ever remain true: God doesn't dice, or God doesn't throw dice. But obviously, the gods do throw dice. If there is not just one monotheistic God, relativity theory risks to be contradicted or refuted. And so, a new schools of physical research could become the future Nobel Prize bearers. I think especially of Professor Dr. Anton Zeilinger, formerly at the Austrian University of Innsbruck and nowadays in the most highly esteemed University of Vienna, a quantum theorist with experimental inclinations. Before I come to his famous experiments. Just one biographical note I got from out of Vienna in the main hall on the vents on the walls. There are portraits of each Nobel Prize winner Austria has lived or seen or in the past. But one picture is an empty hole. It's reserved for the day and the year when Zeilinger will get his Nobel Prize and will have dethroned Albert Einstein. And this may happen not in my lifetime, but probably in yours. Because the experiment is crucial for quantum computers and quantum physics against relativistic physics. Two quanta, this has been shown by Zeilinger, can remain coupled even if they travel away from each other. That is, one quantum stays at the University of Innsbruck in some lab, and the other travels through time and space, to my knowledge, 70 kilometers far away. And still they are in phase, they are coupled, they act as if they were one and the same quantum. Yeah? Like twins who resemble each other perfectly. And I even think that this distance of 70 kilometers has been surpassed by about 100 kilometers. This would be half the way from Innsbruck to Vienna, roughly spoken. So the gods do throw dice and make indeterministic effects, anti-relativistic effects feasible. And in Zeilinger's eyes, this communication system of the future and of the actual present has a big advantage over other electronic communication systems, that this channel is immune against interception. Because every device that would intercept this far distance effect would be registered by the twin system and would, that is to say, would disturb the identity of the two twins. And so the human control post of the communication system would immediately know, now we are intercepted, we should better take care and keep silence for some hours or days.